Welcome. Today we are going to see about transmission control protocol. So there are 7 layers in OSI model. The fourth layer is transport layer. The transport layer is responsible for process to process delivery. The main role of the transport layer is provide the communication services directly to the application processes running on different hosts. The transport layer protocols are implemented in the end systems but not in the network routers. Services of transport layer. These are the main duties or services of transport layer. The first one, end-to-end delivery, addressing, reliable delivery, flow control and multiplexing. Then the protocols of transport layer. The two main transport layer protocols are TCP Transmission Control Protocol and UDP User Datagram Protocol. Now TCP. TCP is a connection oriented protocol, which means there is a predetermined virtual path has been established between sender and receiver before starting the transmission. It provides reliable, error-checked and ordered data transmission. How TCP works? Connection establishment, data transfer, flow control, error detection and correction, ordered delivery, and finally connection termination. This is how TCP works. The first one, connection establishment. The process starts with three-way handshake. First, the client sends a TCP segment with a synchronized flag set to the server. Now the server receives the synchronized segment, acknowledges it by sending a segment with both the synchronized and acknowledgement flags set. Then the client receives the server's acknowledgement and send back an acknowledgement and the connection is established. At this point, both parties, that is client and server, have a unique sequence number to track the data exchanged. The second step, data transfer. Once the connection is established, data can be transmitted. Data is divided into smaller units called TCP segments, which include a sequence number to ensure ordered delivery and a checksum for error detection. Each segment is sent from the sender to the receiver. Next, flow control. Flow control ensures that the data is sent at an appropriate rate between a sender and a receiver. TCP uses a sliding window mechanism for flow control. Each receiver specifies the maximum number of segments it can accept at a time, which is known as receiver's window size. The sender can send data up to the receiver's window size before waiting for acknowledgements. Next, error detection and correction. TCP uses checksum to verify the integrity of data in each segment. Integrity of data is an important parameter for data transmission. If a segment arrives with errors, it is discarded. If the sender does not receive an acknowledgement for a segment within a specified timeout, it retransmits that segment, ensuring reliability. Then ordered delivery. TCP ensures that data is delivered to the receiver in the same order it was sent. Each segment has a sequence number and the receiver records segment if they arrive out of order. As I told before, each data segment has an associated with number by which the order of the data is maintained. After the transmission, the connection termination. The sender or the initiator sends a segment with a finish flag set, indicating it has finished sending data. The receiver acknowledges the finishing with an acknowledgement flag. The receiver also sends a finish when it's done sending data. The sender acknowledges the receiver's finish with an acknowledgement. After this four-way exchange, the connection is fully terminated. Timeouts and retransmissions. TCP monitors acknowledgements and timeouts. If it does not receive acknowledgements within a certain time, it assumes the segment was lost and retransmits it. This process ensures reliable data delivery even in the presence of network issues or packet loss. Next, this is a simple pictorial representation of transmission control protocol function. Finally, TCP provides a reliable and ordered data transmission by establishing a connection, using sequence numbers to track data, employing flow control mechanisms, performing error detection, and gracefully terminating the connection when the data exchange is complete. It is a strongest protocol for applications where data integrity and ordering are crucial, such as web browsing, email, and file transfers. In this lecture, we have seen about the transmission control protocol, by which I hope you can have basic knowledge about the transmission control protocol. Thank you.